We did number 6 in class, but I'll go ahead and work through it quickly here for us. Q of x is a quotient, and so we are working with the quotient rule. So if we were to find our Q prime of x, working through this question as we did the previous ones, we have low, D high. Now we have to recognize that our g of x function is not just g of x, it's g of x plus a bunch of other stuff. So technically we have a chain rule. So we'll need to multiply this by the derivative of that inside function. Derivative of x is 1. Derivative of f of x is f prime of x. We do need big parentheses here because we have to multiply by that entire tail, all the stuff that came before it. So we have our low, sorry, I'm moving slow, d high. So here's our high, and this is all of this nonsense is d high. There's a lot to it. Minus high d low, which will just be 2. And this is all over low, low. Boom. All right, let me give us some more highlighty stuff. There's the high, and there's low multiple times. Bloop and bloop. All right, cute. All right, so just like before, we're going to go ahead and take a moment to plug in 0. Because this is a pretty gnarly one and it didn't give us a ton of space, I'm going to plug 0 in like in this actual question. So I'll show you how I can do that without really getting myself into trouble. So I'm going to go be like, okay, this is now 0. That makes that a 0, 0, 0, 0, 0, 0, 0. Okay, just sort of not, it's like floaty above. Not going to get in trouble, hopefully. We'll see. So q prime of 0 is equal to, well, if we do 2 times 0 plus 1, we have a 1, so I don't really need that. And then we'll have g prime of 0 plus, what's f of 0? Okay, let me go find that really quick. F of 0 is negative 1. So I have g prime of negative 1 times, 1 plus f prime of 0. Okay, now I need f prime of 0. I know this is going to give everyone whiplash. So that's a negative 2. So this whole thing is negative 2. 1 plus a negative 2 is negative 1. All right, minus, we already said that that's going to be g of negative 1 times 2. This is all over 1 squared. All right, so we need these two things, g prime of negative 1 and g of negative 1. Did we find those before? Yes, we did. So I'm just going to steal them up from here. So we have g prime of negative 1 is 1. So we have 1 times negative 1 plus, I feel like I made a mistake somewhere. It's quite possible. G of negative 1 was negative 5. Oh, see, I did the same thing I did last time. I changed this minus to a plus. I did that in class. Times R2. So this is all over 1, so I don't really need that. This is negative 1 plus 10. There we go. Gives us a positive 9. All right, so there was our answer to 6. 7 was fun. This has a typo. This should say p of x. P of x is equal to sine of all these things. So sine of f of x, this is another chain rule problem, right? Let me change back to my blue pen. So p prime of x is equal to cosine, derivative of the outside, leave my inside function alone, times the derivative of my inside function. All right, and then so if we were finding p prime of 1, this is cosine of f of 1 times f prime of 1, which means I'm going to have to scroll. My deepest apologies, y'all. I'm sorry. I'm going to need f of 1 and negative 1. So 3 pi over 4 and a root 2. Oh my God. 3 pi over 4 and a root 2. So 3 pi over 4 and a square root of 2. Boop, 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 cosine. All right, let's see how this goes. Okay, and so we need to think for a second. Cosine of 3 pi over 2, I gave you the first quadrant of the unit circle. To get to the 3 pi over 4, though, we have to recognize that 3 pi over 4 is right here, right? We have in our unit circle, I gave you guys pi over 4, which is over here. I don't even know how I changed to a black pen. So we have pi over 4 And for pi over 4, we're at that root 2 over 2, root 2 over 2 for our uh, coordinate on the unit circle. So cosine of pi over 4 is root 2 over 2. At 3 pi over 4, what changes is we are now dealing with negative x values, which means a negative cosine. You could also think about this from the graph of cosine, which we were here and now we're here. So we are moving into this negative land. So this is negative root 2 over 2 times our root 2. And if we actually do this math up here, we get the square root of 4 over 2 with a negative, which is negative 2 over 2, which is just negative 1. Now, again, I was bad. I did not read what we were doing. So common of me. We're looking for the equation of the tangent line. So while I found a derivative at this particular point, because that's what we were doing, and I just sort of went on autopilot and started doing stuff, what we want here is that actual equation for the tangent line. So we need y minus y1, is equal to mx minus x1. And the work I just did was not for nothing, right? This value we just found is p prime of 1, which is our slope of our tangent line at that point, right? Our derivative is the slope of a tangent line. But we do need to go figure out, we have and we're given the x. This part is done for us. But we are missing at this point my y1. Oops, I did not make that a different color. I know we can survive without it, but that's what we need. So we have one more step, and that is to go find, ooh, that's a huge pen. Let's not do that. To find our y1, which means just plugging in to p of 1. So we need to know what sine of f of 1 is. And so that's just asking us for sine of 3 pi over 4. And that is root 2 over 2. Because now we are in the positive version over here, right? So here's our final answer. We have y minus our y1, which is root 2 over 2, is equal to negative 1, x minus 1. There is our beautiful equation to our tangent line and the answer to number 7.